Hi. Today, Group 16 from Wednesday class will present object-oriented programming poster. So, we will start with Akila Ashraf.
Hi, we are from Group 16. So today we're going to present our TTTK 2053 Programming Paradigm Project poster. Firstly, I'm going for the abstract. So the abstract, firstly, is what is the definition of computer paradigm? So there are four definitions of computer paradigms. The way how we're thinking and approaching programming tasks. So before we're going to tackle our code, we're going to think how we're going to approach to settle the code. Second is the guidelines, the methods, procedure the programmer used to create a program. So before we're going to tackle our codes, we're going to look over for the guidelines, the methods, the procedure to ensure our code is organized. Thirdly is how we provide structure and framework for organizing and writing code. By providing a structure and framework, we ensure our code is organized and proper way we tackle our codes. And lastly is how we define our code written type of construct and how construct interact with each other. Secondly, what is the importance of computing paradigm? So for the importance of computing paradigms, there are five. The firstly is conceptual framework. Conceptual framework provide a conceptual framework for understanding, thinking, solving problem in structured and organized way. In this matter, we ensure our code is organized, and the way we tackle our code ensure the efficiency of our codes. Second is the problem solving approach. So there are many different ways to approach our problem solving with each of their own pros and cons. So we must choose our problem solving appropriately according to how we want the effect, efficiency, maintainability, scalability, and software solution. So the third is code organization and structure. It defines how our code is organized and structured. And the fourth is language and tool support. So for programming language and development tool have been designed with specific computing paradigm, allowing a built-in support and feature which help with the programming paradigm concept and principle. So for each paradigm programming have their own pros and cons and how this tool support. And lastly is the learning and skill development. So understanding the different computing paradigms allow programmer to increase knowledge and skill, which allow us to to study in a range of problem solution and troubleshoot and adapt with different programming environment and domain. So with learning and skill development, we will understand many programming paradigm and also know how to tackle our problem. So what we have choose for our group is we have choose object-oriented programming or OOP as our paradigm. OOP is a programming model that have the concept of object which instances of classes that encapsulate attribute and methods. OOP encourage the principle of abstraction, encapsulation, inheritance, and polymorphism, which help the creation of modular, reusable, and extensible software. So the OOP are built to complex entities and relationship, which allow for a bigger application. By encapsulating data and behavior within object, OOP support code organization, data integrity, and code reusability through inheritance and polymorphism. OOP has been used widely in many programming languages, including Java and C++, which has become a main paradigm in many aspects, from desktop application to game development. So the versatility and the scalability, and the importance of code organization make it the best choice of facing intricate software challenges.
The object-oriented programming is a programming paradigm that works with objects in the designing of applications and computer programs. Objects are instances of classes. This paradigm emphasizes encapsulation, inheritance, and polymorphism to create reusable and modular codes. So there is four principles of OOP, which are encapsulations, inheritance, abstractions, and polymorphism. So, encapsulations. Encapsulation is enclosing data and methods within a class, protecting it from external access and modifications. Abstraction is simplifies complex reality by modeling classes appropriate to the problem and exposing only essential functionalities. While inheritance allows a new class which is child to inherit properties and behaviors from an existing class which is a parent, promoting code reuse. Polymorphism allows objects to be treated as instances of their parents' class, enabling different behaviors for the same method. So this is the timeline evolution of OOP.
Next, we're going for the definition and architecture of paradigm. So from figure 5, you can see that OOP is a programming paradigm that relies on the concept of classes and object. The architecture of OOP can be seen on the figure 5, which is the architecture of paradigm. On the top is the class and follow with the object as instances of classes at the bottom. We can refer to figure 3 and 4 for the key principle of OOP, which consists of abstraction, encapsulation, inheritance, and polymorphism. Okay, next we're going for the comparison of OOP and imperative. So the OOP have a unique way in which is structured object that encapsulate data and behavior which allow more accurate model of the relationship entities and can help in use code through inheritance and polymorphism, while the imperative programming use the old way in which is organize the function and then operate the data. It focus more on writing string of steps to handle data and perform tasks specifically. Second, OOP have a higher memory and lower processing speed due to its creating and handling many object instances. In return, it allows for better code organization, reusability, and maintainability, while on the other hand, the imperative paradigm has a better memory efficiency and faster processing speed due to it directly handle data structure and do not need any additional memory for object instances. So for my analysis, OOP is a better paradigm due to its ability to mimic real-world model. It also aids in the organization, encapsulation, and abstraction. Although the performance of imperative is better than OOP, the benefit it provides in coding allow us for better developing in complex system.
Of the essential characteristics of object-oriented programming, one of the main ideas is encapsulation. This means we group together data and the actions that can be performed on the data into objects. It's like putting things into neat little packages. This helps keep our code organized and makes it easy to understand and work with. Another important concept of object-oriented programming is abstraction. This is a fancy way of saying we focus on what things we can do rather than how they do it. We hide the complicated details and only show what's necessary. This simplifies our code and makes it easier to use. Object-oriented programming also uses something called inheritance. This means we can create new objects based on existing ones, inheriting their properties and behaviors. This saves us time and reduces repetition in our code. Last but not least, object-oriented programming includes polymorphism. This allows us to treat different objects in a similar way even if they have different characteristics. This flexibility makes our code more adaptable and easier to extend.
The first strength is modularity and reusability. Classes and objects can be reused across different programs, reducing redundancy. The second one is maintainability. Changes in one part of the code can be isolated, making updates easier. The third one is flexibility and scalability. Polymorphism and inheritance allow for scalable systems with minimal changes. The weaknesses is the first one is increased complexity. OOP can be complex due to abstraction layers and class hierarchies. Second one is memory overhead. Objects and their reference can consume significant memory. The third one is performance issues. It is about abstraction and interaction can slow down the performance. So this is the sample code we use when we learn the Python. So modularity. The person and student classes encapsulate their respective data and methods promoting modularity. Other than that is code reuse. Inheritance allows the student class to reuse and extend the functionality of the person class, reducing redundancy. Other than that is flexibility and scalability. The new types of people, for example, teacher and employee, can be added by creating new classes that inherit from person, making the system scalable.
Final thought, object-oriented programming works well for organizing and maintaining complex software. It accomplishes this by clearly separating and simplifying each component of a program. Object-oriented programming also helps by simplifying the use and reusing of code segments. It can function adaptably with a variety of objects. Object-oriented programming adheres to a set of guidelines to ensure that everything remains organized and modifiable without creating issues. All things considered, object-oriented programming is ideal for creating software that can adapt to changes and remain manageable even as it grows in size.
OOP enables us to create software that functions a lot like real-world objects. These concepts are represented in OOP by objects, each of which has unique properties and capabilities. This facilitates the organizations and comprehensions of our code. OOP also helps us by maintaining separations of concerns and ensuring that modifications do not interfere with other areas of our program. We can make our code flexible and simple to modify by utilizing features like inheritance and polymorphisms. All in all, OOP is my preferred method of writing software since it allows us to create things quickly and modify them as needed, much like when we build with Legos.
OOP is fantastic in my opinion because it makes software more real-world scenarios. It accomplishes this by utilizing fundamental concepts such as grouping action and data into objects, which helps to organize and simplify our code. OOP allows us to create easily scalable and adaptable system. Similar to building with building block, we can reuse components and create new things with a little additional effort. OOP is therefore ideal for a large project that require ongoing adaptation. Furthermore, it's a natural method of designing system which facilitate the management of challenging projects.